Hey, Dustin Vanoy here. In this video, I'll be talking about data lakes. We'll do a quick intro to how we define a data lake, a few reasons why we use them, and then a glimpse at what it looks like to query a data lake with Azure Databricks. So how do we define a data lake? I define a data lake as having varied data. It's built for raw, intermediate, and fully processed data. Some people focus only on a place to store raw data, but I find that really successful implementations, you're going to end up storing at least some of the partially processed and partially cleaned up data, as well as even some final results is my recommendation to include those in your data lake where it makes sense. A data lake is also ready for analysts to use. Whether or not you have a standard way of querying it across your whole organization, you're going to have some sort of standard templates that different analysts can use in order to get access to that data. Often I've seen people build data lakes, store a bunch of data in them, and not really provide a way for analysts to get to it. And so the analysts will go use Excel or use some other tool that they're already used to and not really adopt the data lake, even though it's really powerful and really beneficial to them over the long run. And a data lake is big data capable. So we're planning to store data first and evaluate and model it later. We'll talk a little bit more about that throughout this discussion of a data lake. But the main thing I want you to know is not just a file system, it's not just a place to throw data. We're expecting to get that data back out, and we want to plan for and design it in a way that we can help people get the data they need out of that data lake when they need it. So let's talk about why data lakes. Most companies have a lot of data these days. A lot of the times the website itself is the product and they have a lot of users on those sites. Think of Facebook, think of LinkedIn, think of any product that you pay a monthly fee to use like Spotify or Netflix. All of those are collecting data all the time about how the product is used. Because you're always online, because you're using it in their environment, they can collect all this data about you. And maybe you're in a similar situation. When you're in that situation, you have a lot of data and it comes in different formats and it's not always clean. What we want to do with our data lake is store everything. We want to store data that's coming in as log messages, that's text. We want to store data in JSON or CSV, XML data. You might just have document data that you somehow get a hold of. We want to put that into our data lake and come back and analyze it later when we know what we are looking for. Because we're storing everything, we benefit a lot from no schema on write. So I don't have to know exactly what this data looks like and make sure it fits a specific scheme. When I save it to my data lake, I can do that later on. I can clean it up in additional steps, and I can wait years to do that if I really want to. Though the longer you wait to validate schemas, the harder it's going to be to get everything to line up for your analysis. We also want cheaper storage. This is very possible these days, especially if you're working in the cloud. And what we're able to do is store a lot of data on this cheaper cloud storage that is built in a way that works well with data lakes. Reason number 2 is massive scale. We want to take a whole lot of data and process it efficiently and save cost while we do it. We want to be able to do this in a way similar to what Hadoop does. The short description of what we're talking about is we have this concept of saving the data across a bunch of different disks. In the cloud, that's a little bit abstracted for you. We're saving the data across a bunch of different disks. We're often storing multiple copies of that data, and then we can run code that is meant to work in parallel. MapReduce is the model that Hadoop was built on. Spark is using those same concepts. A lot of other processing engines are out there to run these small pieces of code where the storage lives on different servers and then pull the data back together for that final processing, which gives us the ability to do things we couldn't do if all the data was stored on one disk in one server with our standard tools. We're now doing this in the cloud, which means we're using things like AWS S3 and Azure Blob Storage or Google Cloud Storage to be the storage system, the distributed file system that Hadoop was in the past when we were on premise. We want those cloud storage systems to give us the ability to have hot and cold storage. What hot and cold storage is referring to is some of the data is faster to get to and we pay a little bit more for it to store. Some of it takes a little longer when we query it, but we pay less for it and don't expect to use it as often. So if we need to do a 5-year history analysis that we don't do every day, a lot of that data might be in cold storage, and we can just grab the last year from the hot storage, the first 4 years from the cold storage, and put it all together at runtime without really thinking about it as a developer. We also want the ability to pay for what we use because we're talking massive scale, because we're talking big data, and that's where cloud storage becomes a really nice option here. Reason number 3 is separating storage and compute. When we're talking about using cloud storage like blob storage or AWS S3, we're talking about storing the data in one place and having multiple types of processing tools we can use to access it. In the example I'll show here, we will look at using Spark. We'll use Azure Databricks, which is running Spark, to access Azure Blob Storage. And what we're doing is each team in the organization that needs to query the data could have their own Azure Databricks instance. It's called a workspace, have multiple clusters there. And all the time they're working with data that's stored in the same data lake in a common controlled area, and they aren't stepping on each other's toes because they're reading from the same data lake, doing their processing, and then writing to places within the data lake that are meant for them to write to. So we're separating storage and compute, and we're also giving our teams some amount of autonomy to do what they need to do, use the right tool for the job. They don't have to use Databricks unless your organization decides that's the tool we use, and they can work with the same data without having to move it all around all the time. So let's take a quick look at what it looks like as an analyst who is using SQL to query a data lake through Azure Databricks. So here we are in a Databricks notebook. This is the interface I recommend for an analyst that's used to writing SQL code and wants to do it against a data lake that is built in this case, Azure Blob Storage. It could be Databricks using AWS S3. Those types of things is what we're typically talking about when we talk about a data lake these days. So the first example I want to show you is querying this million songs data set. If you've never looked at it, it's just got a lot of information about a million songs, a lot of details about it. We're just going to pick a few columns from it to demonstrate how similar this SQL syntax looks to standard SQL you would run against a SQL Server or Postgres database. So if I run my cell, it's going to take a little bit more time than some of your databases might take, but it'll be pretty quick if your data set's not that big. A million records really isn't that big for a data lake, but depending on what types of transformations we try and do in the SQL, it could take a little longer. So that one took almost a second. I wouldn't want my website that the users are hitting to be pulling from this all the time, but as an analyst that's kind of exploring the data, getting answers, less than a second is really good. It's not always going to be that quick in a data lake, but that's a really good start. So let's take something that's a little bit more complex. I won't try and explain SQL to you, but basically we're pulling from this table called Million Songs. And then the backstory is I've created a table in Databricks called Million Songs. And I'll show you the syntax to create that in just a moment. After I've created that table, I can just run SQL statements similar to this. I can group by fields, do a count calculation, an average calculation, and end up with results that look like what I would expect in a grid form. I can switch to chart mode if I want. You definitely need to think about and start to tweak with the options to make a chart that looks good. But typically I'm looking at it in a grid mode, kind of figuring out if this data looks right. And then for me, I'm usually putting it into Power BI. You can also export the data. This isn't something you want to make your go-to ETL tool that you run manually every day, but this is a great way to explore data even more, especially if you're more comfortable in Excel or have some other tool that's hard to connect to Databricks but easy to connect to Excel or CSV files of any sort. So this one took almost 3 seconds. So we're getting a little slower, but it's not enough time that I decide to go do something else or leave to get a cup of coffee. So we're able to query this data lake and get pretty good results and think about what we're doing, ask the question, get the answer quick enough that we don't lose focus on the analytics problem at hand. In this case, we're actually querying a little bit bigger table. So it's a Databricks Delta table. That's a really fun topic. I'll do a video on another time. But now we're up to 1 million records. Before we had about 500,000. So running a similar type of query against that 1 million records, we're going to get very similar results. Now, the other way I can do a table in a data lake that's interesting, especially if you're going to be creating your own tables, is I can create an external table. What an external table means is that as the data is updated under the covers, I'm going to see the latest data that's added to the folder. In this case, it's called songs data 001. And maybe once a day, once an hour, there's a job that's putting more data into that data 001 folder. In this case, I have a table that's always going to point in that folder, always use the latest data, but it'll apply a schema to it. So this is where the schema on write that I talked about earlier starts to come into play. This is the first time I'm defining a real schema on this data, even though there is an implied schema by whoever put it there in the first place. So this is the syntax for an external table. It looks a lot like Hive syntax if you're used to Hadoop. Typically it's exactly the same. And when I get into querying that external table, I start to have the same type of functionality that I did before, but it's going to run a little slower. So let's take a look at what it looks like to hit that external table. So here's our external table results. I skipped over a little bit because it took 12 seconds to run that. But that's kind of an example of external tables typically perform a little bit slower, but we have this benefit of we don't have to rebuild and reload data to the table all the time. And then the other thing you can do as an analyst especially is you can create temporary views of data, and this is just showing the syntax for that. We don't really need to run this. I have more examples, other things. This code is in my GitHub repo if you want to go check it out. But that's what the analyst view SQL only of querying a data lake looks like from Databricks in particular, and how we would create temporary views, external tables, that kind of thing. So you may not even have to get into writing Spark code, writing Python, Java, or Scala code to work with a data lake, and that's the main thing I want you to take away from this example, as well as kind of the timing, that if you're used to working with a database that's like specialized and fine-tuned, is probably much faster than what you just saw. So that was our demo. Let's talk about some best practices. When you have a data lake, you end up storing a lot of data. It's in a folder structure, and so you can organize it the same way you could organize a file system. But a metadata portal that is helping people to find the type of data that relates to the marketing team and the finance team or your website usage, that type of portal becomes more valuable than it's ever been before when we're working with the data lake. The other thing to know about a data lake is, for as far as good practices go, is to not just store the raw data, but to make sure you're storing back some of the final process data and some of the intermediate results there, so that analysts that are trying to use the data don't always have to start from scratch and do all of the cleanup that happens against the raw data. Another tip for you, it often goes well with the metadata portals, to have some way of certifying data sets. If you have raw data, if you have completed data that may go to the CEO level, you'll want to be able to distinguish for people whether it's raw or whether it's that kind of certified final result that is going to be used by the decision makers at the company. Another best practice is not too much governance. And before you freak out, what I mean by this is you have to give some amount of default access to the people that need to use the data lake. So if you have analysts in marketing, an analyst in finance, an analyst in the product team, you may have a default set of permissions that they all get to read data that hopefully is anonymized data, so they don't really get to see anything in particular about the users that have created these events, but they can start to get some ideas, get some results from the data without having to submit a ticket and wait 2 weeks to get access to the most basic data set in your data lake. So I've seen a lot of data lake implementations where it's so hard to get access to the data that it doesn't get used. And so my point is to think about that as you go, while still keeping your data secure and your customer privacy protected, even from your internal users that really don't need access to it. So thank you for joining this video. You can find more content as well as more demos of Databricks on my website, or check out my YouTube channel.